there was quite a variety of sea level changes that happened during the last glacial maximum and at the end of the Ice Age. So in some areas, for example on the west coast of Vancouver Island and Haida Gwaii or the Queen Charlotte Islands, the sea levels were actually much lower as they are today, while in other areas like the Lower Mainland the sea levels were much higher as they are today. So for example the sea levels out at Haida Gwaii were up to 150 meters lower than they are today, while they are in the same time up to 200 meters higher here in the inner coast on the Lower Mainland, for example. So there are several reasons for this. One reason is global sea levels were very different at that time because of the ice that was locked, because of the water that was locked in the ice sheets that covered all of Canada and northern Europe. The sea levels during the height of the glaciation were up to 130 meters lowered across the whole globe. And when the ice started to melt, of course, those sea levels would slowly rise again. Another thing that happened during the Ice Age is the isostatic depression or uplift, as we call it. And what that is the ice masses, which are very big in some areas, like in Vancouver they were 2.5 kilometers thick. So these ice masses basically they depress the crust of the earth and the mantle below the crust. So this mantle is a kind of a plastic, viscous material that can be depressed. So in the area around here the mantle was probably depressed 200 to 300 meters. So which means that even though the global sea levels were lower in this area, the relative sea levels were higher because just the whole Lower Mainland, for example, was depressed by 200, 300 meters, and it was just in front of the big ice field. So that explains why we have such a difference in sea levels on the coast here. There's a third effect that also comes in here, and that's called the fur bulge effect. So again, because the mantle and crust underneath the continental ice is depressed, we have the material in the mantle is kind of pushed outwards towards the edge of the ice margin, and that the ice margin was of course just right here in the Lower Mainland, Vancouver Island area. So that means that while the crust and mantle was depressed in the inner coast, all the material was pushed out towards the outer coast. So the outer coast was actually uplifted in the same time as the inner coast was depressed, and that even increased the difference in sea levels between the outer coast and the inner coast. And of course, after the ice retreated, those forces would balance themselves out. So we would have the crust rising again. So we had isostatic uplift on the inner coast or Lower Mainland here, and we would have isostatic falling of the area on the outer coast, or a collapse of the fur bulge, as you could call it as well.